Okay. Hi, everyone. Welcome to the March edition of the Open Security Summit. Thank you, everyone who's here. And today we have a session about diagrams, one of our favorite topics, diagrams and threat models. I am joined today by Marius and Ahmed, who I'll give a chance to introduce themselves. And today we talk about how C4s meet threat models. And we get to find out a little bit more about what are these C4s, maybe some of you know, and this will be kind of the story of a love story between architecture and security. So let's go to the introductory slides.
Brilliant, I'm first. Hi everyone, I'm Marius Clark. I'm the CISO at Job and Talent and virtual CISO at Zava. And fun facts about me, I'm dyslexic and dyslexia is my superpower. So as you can see, I won't have any slides myself. I will be jumping in and out of other people's presentation. I'm colorblind. As you can see, there's a lot of numbers there I don't see. And I like theoretical physics. I'm a geek when it comes to physics, and I like to break things and try and figure out how to put it back together. That's me. Thank you, Petra.
And hi, I'm Petra. I'm the senior cybersecurity engineer at Zava. I have a passion for threat modeling, vulnerability management, all things security, architecture and design, cloud security, and the SSDLC. I'm also a Wordly Maps enthusiast, and I do some machine learning as a hobby. And go for it, Ahmed.
Hey, hi, I'm Ahmed. I'm Senior Solutions Architect at Zava. Originally from Egypt, living now in the UK, have a background of mechatronics engineering. What I do usually is software engineering and architecture, and my areas of interest are startups, serverless, and health tech. So you can find me doing one of them or a combination of the three of them. So yeah, that's me. I think we can kick off now on the topic. So the first thing is why we need an architecture diagram. What we have here is a Wordly map, and I want to explain it in more details, but easily it's the easiest way to read it is to put needs on each of the lines. So software engineer needs onboarding. They also need knowledge sharing, and post onboarding and knowledge sharing needs documentation. And to have a good documentation, you need good architecture diagrams. And our tool of choice is C4 model for architecture diagrams. So this is how you read the value chain of needs of software engineer and how we reach it, the C4 model. And one of the ideas of Wordly map is that you always want to move things to the right to be better at. So if you want to improve your architecture diagrams, if you want to move your documentation, you probably want to move your architecture diagrams to the right and makes it better. And this will improve your documentation and then improve your onboarding and your knowledge sharing. So this is the idea where we start, where we map the C4 model and how we picked it up in the beginning. So architecture diagrams. When I asked my first boss in my first job, when he asked me to draw a diagram, I asked him how to do it. And then he told me, well, actually, it's just boxes talking to each other. Which, yeah, it's a simple phrase, but actually it gives a meaning. So if you think of boxes talking to each other, here are two boxes. One is asking, okay, do you have the time? Yeah, it's 12 p.m. And you can translate this into an architectural diagram. So you have system A, which calls system B, and you have an endpoint that says, okay, give me the time. And system B responds back with the time. When you think of this concept, you start asking questions like, are these boxes allowed to talk to each other? And what kind of language they will use in communication? And what kind of permissions they have and what kind of messages they are allowed to talk in. And this is why having an architecture diagram is important, because it gives you these details. So we wanted to have a single architecture view of all the components we have. And usually you see something like this that evolves in each company after a few years. So people start adding systems, connections, and you start putting different concepts in diagram to explain things. And it gets very complicated and you don't know which level you are in. And then it becomes hard to digest from anyone. And then you end up as you don't have any diagram. So we built the C4 model. And the idea behind C4 model is that you can zoom in and out into different systems. So you start with drawing a complex diagram, which maps your system, your domain, your capability. And then you zoom into this capability and try to break it down into a container diagram, where you put all the systems that constructs your capability or your domain or context. And then you can move into each of these components and see how this service is built, what kind of technologies, what different components are inside. And then you can do an extra level and go through the code and map all your modules inside the code to understand it better. The minimum for C4 model is to draw the first 3 diagrams. The fourth one is optional. It depends on your need for the team, but the 3 first ones are very crucial to transfer the knowledge and understand the systems you have. This is an example of a C4 model. So this is an internet banking system. You can see here that you have one actor, which is the personal customer of the bank, and this system interacts with 2 external services. So this is a context diagram. It just explains the capability you have, which is the internet banking system, who are the actors, and what kind of external services it deals with. This is kind of important because it's not very technical. You can show this to a product owner, to business people, to marketing, and they will understand it. And it's not hard to explain. And then you go to the next level, which is the container diagram, and you zoom into the internet banking system. So the internet banking system consists of 2 mobile application, a website, and a web application, and then you have an API and database. So all these 5 components constructs your internet banking system. And you can see that you still have the same 3 actors you had in the beginning. So you have the customer, you have the email system, and a map frame. So you just zoomed into the internet banking system. You didn't write anything new. And then you zoom into one of the applications. So that's the API application. And the API application contains different controllers and modules, which interact still with the 3 systems you used before, and also the database. So you zoom the next level into these systems. And then, just a simpler example to explain this. So this is a prescription management system that I put together to explain how the concepts work. So for example, we have this system. We have a doctor that creates a prescription. We have a patient that can download a prescription. And we have a third-party system that we can send prescriptions to digitally sign. And if you look here, you will find something that I like to keep track of in my drawing sessions, which is the number of the lines. So here you can see that we have 3 lines. And this count is really important because when I start to go into the extra level, I make sure that I have 3 lines at the end. And that means that all the communications that are going into the system are still mapped, and I know where they're going and what kind of actions they do. So this is the next level, for example, the prescription management service. Now I zoomed into it, and I have 3 services that construct it. So I have 2 single, sorry. So I have 2 single-page applications, and I have an API that serves it. And the doctor goes through the doctor system, for example, and you can see that the C4 gives you more details because you write the technologies, description of the system on each of them. So you have a lot of details in this simple diagram that you can send to any engineer, for example, and they will understand what the system does, how each service communicates with each other. Then you zoom into the API service, and you still have 3 lines going into that service as well. So you keep that keeping that count makes your drawing accurate, and you keep track of all the communications going into the system. So this is the component level, and this is an alternate view of the original C4 model. In this level, I'd like to use the infrastructure components instead of just the blue boxes. because it gives you an additional level of details that you don't have to describe. And it's easy to communicate this with different teams, like infrastructure or DevOps, because they can digest this easily and understand it. So here you can see you still have the 3 lines. We went back and forth between the system. You can zoom out and go back to the API. You can zoom out to the context. Then you can zoom in and understand the system on different levels. So this is really easy to understand, to communicate. And you can have a single architecture view where you have the big context, and then you can zoom into each area. It's similar to Google Map, for example. You see the globe, and then you zoom into a continent, into a country, and then you can zoom out and go into a different country and see the details of the map. And I think this is where I hand over to Petra.
Okay, so the reason why we as a security team really like this system, the C4s, which thank you, Ahmed, for explaining so well. I think they're quite cool, is because we saw this as a really good bridge to bridge the gap between architecture diagrams and data flow diagrams. The biggest struggle in threat modeling for anyone that works in security knows that it's the initial step of making a data flow diagram. There's like various methods to do it, like diagramming as code or using, Draw.io or Visio or whatever other tools there are out there. But at the end of the day, if you want to have a good threat modeling session, you need a good data flow diagram, right? And you don't want to spend the whole threat modeling session that you have, the precious time that you get with your developers, to actually spend on diagram. So, this is how we actually decided that this might be a good way to use security to drive and implement engineering processes and to leverage good engineering processes to instill quality security architecture reviews, basically threat modeling. So I
can jump in here as well, Petra. So our biggest challenge when we threat model as an industry is that if we don't have good diagrams, we spend the majority of the session trying to understand data flows, right? We query the developers. There's a lot of discussion and debate that goes how the flow looks like. And by the end of the session, we drew a diagram, which looks a lot like the C4 diagram, and we spend 0 time on threat modeling. So this is a nice way of actually creating the C4 diagrams prior to the threat model. And when we do a threat modeling session, we're not actually drawing, we actually threat modeling. And that is actually our biggest challenge when we actually threat modeling, is that we don't have accurate diagrams, right?
Yeah, and this is how we decided that we're going to actually ask any dev team who reaches out to us to do a threat model, we ask them to do a C4 first. Because that way, basically, the architecture team is happy because we finally have diagrams everywhere where we need them, and we can have a good overall picture of the whole application, which helps it future development, helps it scale. But at the same time, we also satisfy security requirements and helps us bridge the gap between, classic diagrams and data flow diagrams. So if you go to the next slide, Ahmed, please. Yeah, that one. So I just wanted to add a great value that we had during our experience of implementing C4s is actually us, the security, sitting on these drawing sessions that Ahmed was leading with the developers, because it was actually a mini pre-threat model, because Ahmed was going through all the flows with the developers and trying to get a picture of all the systems. And at the same time, it made everyone think about how one system accesses another system, what is the authentication, what requests are being sent back and forth, what data is being sent back and forth. And it's a really good way to actually make developers and architects think in a security kind of way, because, at the same time, you doing an architectural diagram, you're getting to know your application, but you're also thinking about how you're going to protect the data that flows around. And also, if you see, you know, some applications have the classic mermaid diagrams and nothing more. So, you know, what has Ahmed shown is actually a really, really good way to bridge this gap, to jump from, you know, simple mermaid diagrams to data flows. And, you know, as a lot of you guys know, and, you know, Marius can maybe even confirm, a lot of struggles we had with data flows is that you need actually a good skill set to make them.
Yeah, I can actually expand on that. It's not easy to create data flow diagrams, right? A lot of the time we know how the component works, but we don't fully understand the flows and interactions between the different components. And so one of the biggest problem we had at the beginning is my component here, but we don't know what interactions, we don't know what calls it makes outside, or what inbound calls it makes, or what actually is the flow. We know it calls something, but we don't know when.
Maybe I'll add something here. One of the good things I found that you need to ask a lot of questions when you draw the diagram. So engineers will give you as much information as you ask for. So you need to keep digging deep and asking them questions. Why is this box here? How this line goes from here to here? And this is why I keep count of the lines, because when I move to the next level, people forget about the lines above, and then you end up with some systems that you didn't draw something for. So I keep count to make sure that I cover everything, and I do like final reviews that I can.
So when you create your C4 diagrams, you look at the final product and you see the lines, and if they don't match with the higher level of C4, you realize something went wrong, right? And you've got to revisit where that went wrong.
Exactly, yeah.
Yeah, and like you said, you know, when you ask all of these questions and start prodding, you actually realize that a lot of people, because, you know, teams change, developers change, you really realize there's this gap of like people not knowing a lot about the application unless you prod them and make them think about it. And when you have finally create these C4 diagrams for the whole company, it's a good way to hand over, like, you know, Ahmed initially said, it's a good way to hand over to any future developer so that they can just crack on and do their job instead of thinking of how their piece of the puzzle will kind of fit into the big picture. I see Timo has said that he's got a problem with diagramming brought to a session that you cannot follow so fast. How do you slow down developers to be able to follow the explanations? Timo, would you like me to unmute you? I can just, so you can just expand on that question. I'll unmute you if you want to expand. If not, I think what I gather from this is basically that sometimes, you know, when you have a diagram, it's really hard to follow it, right? And it's really hard to understand what the author was trying to say. So I think
that's no, they are actually there in my, so I can explain how I do it. So they sometimes say, I have a diagram already, and I said, oh, please don't bring it because we need to understand it together. Because I have the assumption that one person in the team draw it, or two, and the others not. So they have a bit more background, but I think they are also overwhelmed with the information. So that's why we draw it together and spend time on it. And so afterwards, we find threads. So, and the question is, does it help me to zoom in and out? So does it mean that I have to look at it beforehand before I go to the teams, or is it so that I do it alone, the thread modeling?
Do you want to take it, Petra, or should I take it?
Go for it, Marius.
So it's a mixture of both, right? You want to be able to have a good view before you go to the thread model or what you actually thread modeling, just for you to have an understanding of the environment, the components, and how to steer the thread model in the right direction. The second part is that you want actually the time that you spend threat modeling to be spent actually discovering the threats, not just diagramming, right? So we use the C4 diagrams to create data flow diagrams, but at the same time, we still do the discovery and validate those flows, but we have that baseline, we have that base to go on, because otherwise we spend an hour or two trying to diagram virtually as well. It's not easy to diagram nowadays. It's not a whiteboard that we can all jump on a whiteboard and draw a diagram. It becomes a lot more time consuming drawing a diagram online. So having something prepared that you can actually look at as a security team and build those understanding of what the system is, then take that and actually break it apart during the threat model session. Query those flows, make sure that they are actually, those flows are the ones that you actually are threat modeling, because a lot of the time there might be a flow that hasn't been thought, because from a component perspective, it's not actually an interaction with that component directly, right? It's the infrastructure that's calling the component, or it's the infrastructure that's doing some action on that component. So we use the actual diagramming to be able to drive the threat model rather than base the threat model just on the diagram.
Yeah, exactly. And that's what I wanted to say. So I don't want it to look like we're replacing this with a data flow diagram or replacing a threat model session with that. We still have the developers on the threat modeling session, and we still have them go through the flows. And I'll just actually explain that on the next slides. If you jump to the next slide, Ahmed. So this is, the love story of C4s and data flow diagrams. All right, so if you think about it, this is an example of a simple component diagram. And if you think about it, all you need to do here to make it into a data flow diagram is add a trust boundary, or trust zone, add HTTP or HTTPS request methods, clarify and verify the flows. So there's a lot of arrows here, there's a lot of flows here. So you have this diagram in Draw.io, and that, that's not a replacement for a data flow, but you put that up on a threat modeling session, and then you, first of all, validate and clarify every flow, but then you add what's missing to make it a proper data flow diagram. And then you get to the threats. But at least here you have all the components on the table. You have everything that you need on the table. So you don't need to spend time, importing icons and, adding arrows everywhere. All you need to do is just make a few tweaks and adjustments. And if you go to the next slide, Ahmed. So this is on top of Ahmed's, prescription system that he showed in a couple of slides before. And I should have probably just added that one to compare. But what it is basically, I've added to his component diagram, I've added users. So I've added the patient and the doctor. I've added trust boundaries, which were not present before. And for example, here, what we would do additionally on a threat modeling session is just clarify a little bit more about this patient account and doctor system boxes. For example, we would probably ask, how does it work? Does the patient access it through an iframe, or the doctor system? Is that something that's also hosted in the VPC or outside of AWS? But as you see, not a lot of things need to be added to the diagram. It's just a few tweaks, just a few clarifications that we do. We add a couple of, like the patient, the doctor was even easy to add because I just copy pasted it from the context diagram. That was the first layer of the C4. So it was pretty straightforward and easy for me to create like a prerequisite for a data flow diagram, turn up on the session and just, add a few bits and bobs, clarify a few bits and bobs, and get straight into the actual threats and, security controls. So yeah, also like here, maybe we would verify whether this digital signing provider is a separate entity, a third party, or is it something also within us, But yeah, as you see, it just makes everything so much more simple.
Maybe one thing about C4, the colors has a meaning. So for example, the gray color means it's external system, it's not ours, and the blue ones mean it's ours. So if you see the patient, for example, this could be anyone out of the company, while the doctor is someone that is employed by the company. And same for the digital signing provider, it's an external system. So even the colors of the C4 model gives meaning to the diagram and makes you probe some things more and ask and dig deeper on some items.
So it helps us create that trust boundary as well, yeah? An external system versus an internal system, an external entity versus an internal entity makes it easier to draw those boundaries.
Yeah, exactly. Because then maybe in this case, we actually put the doctor system all within the same boundary if the access is from within. So yeah, thank you for that addition, Ahmed. It's also another perk of a C4, having a C4 before data flow. And if you go to the next slide. Right, so of course, we have Wordly Maps again. Can't go a session without it. So similar to Ahmed's Wordly Map, I just wanted to kind of point out how this is all kind of comes into place. You know, we have product security and the architecture team as anchors. So we have two anchors, which is not typical for Wordly Map, but I always like to make my own versions of things. So we have two things. And, you know, as you see, both product security and architecture team, we all need diagrams. And, you know, to create a data flow diagrams, we found that C4s are actually super useful. So, and what it is that the threat modeling needs the data flow diagrams, but sometimes also C4s need data flow diagrams if, you know, you don't have the right people to talk with. That's why I kind of made that line to still make it connected. But, you know, the point here is that if we move the C4 diagrams to the right, we actually help also move threat modeling to the right. And, you know, in this scenario, the security team is under like, you know, all the way to the left, which means it's bespoke, it's unique, it's rare to find. So we're not a commodity in a lot of companies. You know, in a lot of companies, you have maybe one person who's a, you know, engineer and one person who does, you know, risk. So, you know, having the architecture team implementing these C4s is also a way to help us kind of scale security. And, you know, also with the help of security champions as well. So, you know, if by moving the C4 diagrams to the right, we move threat modeling to the right without even having to move the security team to the right. So, you know, build more security team and make it more of a commodity. So I'm just presenting this as a way to kind of cope with, you know, the shortage of security people within a company. And actually, it's not just that, as I said initially, it's also a way to ensure quality and scalability of the product itself.
So I can jump in here and summarize everything. Why C4 meet threat models? As I spoke before, the biggest challenge that we have during threat modeling and in general when we come to engineering is documentation and diagrams, right? They're never up to date. It's hard to maintain. Very, very rarely is in priority to create them once you're developing. It's a rare thing to have an accurate diagram because you develop, deploy, and then documentation comes later. And then by the time you do the documentation is out of date. So when we do a threat model, it's very important to have an accurate diagram to go on. To Timo's point, we are not trying to replace drawing during a threat model. We are trying to basically get an accurate picture of the components and everyone on the same side whilst we are threat modeling for threats. Our main priority during a threat model is to brainstorm and understand the threats on those flows and actually identify risks. We are quite small as a security team. We don't have time to review all diagrams prior to coming to a threat modeling session. So we actually use the C4 diagrams, which give us that different level of view. I can look at C4 diagram at the high level. I can look at a bit more at a component level and understand a little bit more about the component. And then when we come to a threat modeling session, we actually validate those flows and identify the threats and risk on those flows. And based on Petra's modeling maps as well, it's a common objective, right? We want to have accurate documentation, accurate diagrams, because it's easier to do security, it's easier to do engineering and knowledge base, and it's easier to troubleshoot a component when it goes wrong. When you actually know how it fits together, it's easier to do quality of engineering and fix issues, because you can always reference those C4 diagrams, and it's very easy to actually go back and modify them and iterate on them. Where that big view that Ahmed showed of the big diagram, that used to be a poster in someone on a wall somewhere, and it was 3 years out of date. And then when there was a troubleshooting issue, you go to that and it was never accurate. I believe that C4 diagrams is a way of having a more maintainable diagram. And when it comes to security, we are 90% there when it comes to data flow diagrams. And with that, I will open the floor to any questions. And Petra, we've helped me unmute you so you can ask your questions.
I also just wanted to add that having the diagram in 4 layers as a C4 also helps with its scalability, because if you develop a new feature on one of the containers, do you mind going back to one of the container diagrams, Ahmed? Yeah, a little bit to the container. Yeah, there we go. So let's say that, in this scenario, we zoomed in on the prescription management system with the component diagram. But let's say that the doctor system evolves into something far more complex. We add multiple new features to it, and we want to do a threat modeling on that. We can easily make just another component diagram into it. So we don't have to create a whole new diagram just for that. We can just zoom in into a component diagram, visualize that, create some new data flow diagrams on top of that. And this is what it helps it scale. I mean, ideally, we would all have this in code and scale with coding, but this is, I think, a great step forward into that direction of having scalability of diagrams, but also like really good context visible on every single architecture diagram. And yeah, open the floor to if anyone's got any questions. Pooja made a comment, yeah, that this is helpful. Yeah, I agree, because it shows assets, and you can show the cases of the application and the infrastructure as well. So it saves time on going through documentation. Yeah, I agree. So this is almost as if it's documentation in a lot of ways, because instead of having everything written down, you can kind of see it all. Anyone else got any comments or questions, anything to add?
Very quiet audience.
Yeah. I guess we were pretty clear then. Okay, well,
someone's asking a question. Have you used any other modeling languages or frameworks, UML, SysML, ArcMate, and do they compare?
I've tried UML. I've used Plant UML. It gave me a lot of headaches, to be honest. Yeah, exactly what Abbas is saying. Plant UML is super buggy. It was great for small diagrams, but it wouldn't scale. So like if we had a big chunk of an architecture piece, it would be so hard to introduce new pieces, because it would just start the components would just start flying all over the place. So yeah, Pooja, there you go. Plantio tedious and time consuming. Yes. Yes. I remember I spent hours and hours sweating over it, trying to make it work because I really wanted to have some kind of diagramming code, but at the end, yeah, gave up on that. And I think, as I said, I think this is a great way to try and make them scale without coding. So yeah, this is kind of why this is my favorite so far.
We had some of those already. So each team had their own way of diagramming, but the C4 model was the easiest one to be understood by everyone. And you can also explain it to non-technical people. So we took this as an approach, as a standard, because also it makes it easy if you send the diagram to anyone in the company and they are familiar with the C4 model, they will pick it up right away. But if you send them something that is written in a different standard or different format, it will take them time to understand it. So having a common way to do it is important. And we picked the C4 model because it was the easiest to understand by everyone.
And Ahmed, you can answer the question from John Renshaw.
Yeah, so there are different ways to create the C4 diagrams. The way we use, now we use Draw.io as a plugin in our documentation system. And the way we use Draw.io, because it's easy to just create a new document and then start diagramming. You could do it as a code. So I think there are some Visual Studio plugins where you can just type the diagrams as a code and then it renders the diagrams. But it's hard to do this with a group of engineers because usually this is more of a whiteboarding thing when you need to collaborate and you need to look at something visual to get a quick feedback. You can translate it later to a code, but we're working now with Draw.io and it fits the purpose for us. I hope this answers your question, John. Thank you.
Yeah, I find it super convenient that it's also within, you can embed it within Confluence. So you just basically create documentation, even threat modeling documentation, and then you just embed the diagram into the page because then everyone sees the diagram. It's not scattered all over the place. It's in one place in Confluence, and everyone's got, who needs to have access to it, has access to it.
Any other questions? No, I think I can just add one comment. I think from when previous to having C4 diagrams, we end up having to do 2 sessions in thread modeling. The first session was actually to create the data flow diagram, and the second section was actually to do the thread modeling. Since we have C4 diagrams, we have minimized the time we need to spend on the thread model by half. We only need that 1 session now because when we do have this C4 diagram, we can see all the different views prior to the actual thread modeling, and then actually thread model the component version, which validates the flows, asks the questions on the infrastructure that those components sits on, and thread model those. So we managed to half the time that we spent on a thread model with the same outputs that we had in the previous one. But I just want to make sure that I address the previous comment that we are not replacing the brainstorming during a thread model, because I 100% agree that that's the best function of a thread model. It's not just the discovery of the actual threads, it's actually the brainstorming activity that goes on. It sparks a lot of thought. And I think back to Petra's point, when she was involved with Ahmed creating these C4 diagrams, the questions Ahmed was asking, it's exactly the same questions we asked in a thread model. Do you want to, what's the 4 Ws, Petra? You remember them?
Sorry,
the 4 Ws we do in thread model. What we are developing, what we do, no, it's not 4 Ws, is it? I got confused now.
Is it 4 Ws?
So
what we're developing, how's it working? What if something goes wrong? That I'm dyslexic, so it might not be 4 Ws, it might be 3 Ws, but it addresses the same questions that we ask. What is being developed? How's it working? what's the interaction with the other system? What happens if that's a component breaks? And again, I think the other thing that you can see from these diagrams and taking it back to the engineering, it's the single point of failure of a component, right? If you have one component that all the others are talking to, it's easy to identify the single point of failure, that system that could go wrong.
Yeah, and it's really good because having these diagramming sessions with devs outside the context of threat models, it just kind of reiterates on the importance of doing threat models, because then they realize that they, while they're doing diagramming for architecture, they're finding flaws, and it doesn't have to be security flaws. It can be even just bugs, some kind of, application flaws where things can go wrong. And, developers, actually engineers, start to get a better view of the value of threat modeling itself, and they might be more proactive and want to do it themselves as well.
When you start growing and you find a lot of lines going into one component, or coming out of one component, you realize that something is not right here. And either it's security issue, architecture issue, performance issue. So there is something wrong here, and then you need to look at it closely and see if you can improve it.
And I think that's the real value of it, really. It's not just the security aspect, it's not just having the documentation aspect, is that it gives you the ability to see visually where things can go wrong or what things are causing an issue, very visually.
Yeah, true.
Brilliant.
Cool. Well, thank you everyone. Oh, then I found what can go wrong, what are we doing to defend against threats? How are we validating the strategies implemented? There we go.
Brilliant. I knew there was 4 W's.
I think W's, I thought it was just 4 questions, but yeah, I might be wrong. Cool. All right.
3 W's and 1 H by the looks of it. 1, 2, 3. Yeah.
All right. Cool. Well, thank you everyone for contributing and for your questions. There were some really good questions there. And thank you for, hopefully maybe this helps some of you guys, within security teams or even, dev teams, to see how to bridge some of the gaps that are present, continuously present within, security architecture and, engineering as well. So yeah, thank you everyone for attending.
Thank you. Thank you. Bye-bye.
Bye.